So bearings. When you're dealing with bearings, you have to remember that we always use our 3-figure bearings. This is when we're talking about these true bearings. True bearings. This is this 3-figure bearing. You always have to think about the following things. That the angle is measured from north. We always measure, so here's north here. We always measure around from north that way. That's clockwise, around from north. We always measure it that way. It's always measured from north. That's the true bearings. And that's what we talk about in further maths. That the angle is measured in clockwise direction to the bearing line. So, yes, as I said, we measure, there's our north line there, and we measure clockwise around from it. It's always measured from north, clockwise around. The angle of rotation may take any value from 0 degrees to 360 degrees. So there's 0 degrees there, that's pointing north. 90 degrees points due east. 180 degrees points due south. 270 degrees points due west, and then back around again. Okay, so you can see our true values here on the outside, and these little ones showing some measurements inside. Often you'll see the symbol T to indicate that we're talking about a true bearing. Okay, so for bearings less than 100 degrees, you still have to use the 3 digits, with the first digit being a 0 to indicate it is a bearing. For example, 0.45 degrees, 0.78 degrees. So why do we use bearings? It's so that when you're describing a direction, people always know then the direction that you are headed in. So if you just say to someone, oh yeah, go 45 degrees that way, do you mean from north? So that's why we use true bearings, so that people really understand, okay, that's the direction you are heading in. If you've ever watched, movies where army movies or war movies, and they talk about, the enemy bearing so and so, they're talking about this type of thing. Where is that enemy? In most cases, when you're asked to solve problems, you are given a sketch, okay? You're given a sketch. When it's only described in words, you've got to do that sketch, and you've got to be really, really careful. Now, even if you're given a sketch, I always recommend doing another little drawing of the situation, because their sketch might involve other things like buildings, but you really want to get it down to the triangles, because once we get it to the triangles, we can see how to solve it. So the sketches of these situations need to be converted to triangles with angles and lengths of side included. This is so that we can use things like Pythag, our trig ratios, even area of triangles, sine, cosine rules, sometimes similarity. All of the things we have been learning about can be used to solve bearing questions. So I'm going to go through now how we might read at these bearing questions and information. So, some hints. Carefully follow given instructions. So, we really read all the instructions and information given. Always draw the compass rose at the starting point of the direction requested. So this is what we'd call a compass rose. So we always show north, and you'll see on any diagrams that we'll do a little arrow pointing up to north. Okay, so that's the point. It might be point A, and we're showing north. At the bare minimum, we show north. okay, because that's where we're always measuring from anyway. Next off, our keywords are from and to. Right, this is absolutely vital. This is where students always get confused. I know in English and EAL, from and to probably aren't words that you highlight, but in maths, we highlight them. So from gives us the starting point, and to gives us the ending point. So here, I'm talking about the bearing from A to B. So you can see here I've got point A, a little north there, and I'm going to B. I'm starting at A and then ending up at B. So from A to B. So you can see I've measured that bearing from north down to B. So it's from starting point to end point. And as you can imagine, that is very different from the bearing from A to B. Here, I'm starting at point B and then going to A. So that's a very different type of thing. Here, that's somewhere between 90 and 180 degrees. Here, that's more than 270 degrees. That's very different. So you've got to pay attention to the from and the to. So from gives you your starting point, from. To gives you your ending point, to. So when you're asked to determine the direction to return directly back to an initial starting point, it is a 180 degree rotational difference. So you might get told that Frank walks from here to there, then back again. Okay, so for example, to return directly back after heading north, we need to change the direction to head south. So here, so Steve Rogers, he's started off going 135 degrees to some point, okay, and then he has to head backwards, has to head back to his base. So he's got to do a 180 degree turn and head back. So his return bearing is at 135 degrees plus 180, because he's turned around 180 to go back, to give you 315 degrees true. So here's another example where they're returning directly back after heading 290 degrees true. So they've gone 290 degrees that way, and they're heading back directly. Now here we are subtracting, okay, because we're going back, we're doing that anti-clockwise. Up here, that went clockwise, so we're adding. Here, we're going anti-clockwise, so we're minusing. So we're heading back 110 degrees true. So here I've got, this is a complex example, but let's get through it. Soldiers on a reconnaissance, so that's like a spy mission, set off on a return journey from their base camp. So that's where they've set up, and then they go off and do their missions from there. The journey consists of 3 legs, so you can think of that as 3 parts of the journey. The first leg is on a bearing of 150 degrees true for 3 kilometers. The second is on a bearing of 220 degrees true for 5 kilometers. Find the direction to the nearest degree and distance, correct to 2 decimal places, of the third leg, the third part of the journey, by which the group returns to its base camp. Okay, so first step, draw a diagram of the journey and show a suitable triangle. We always start off drawing our diagram. So you see we've got here our base camp. First leg was 150 degrees true. So I've started with my north and I've come around and drawn a line there. So that's of 3 kilometers. Okay, to get to then that point. Then from that point, we went 220 degrees true for 5 kilometers. So 220 degrees true is around like here. So we've got north there, measuring around, so it's roughly there. And then I put my line for 5 kilometers. We are being asked to find that length there, but also the direction, that true direction. Okay, so oops, not very straight there, but you get the idea. But it's that angling there. Okay, and this is it sort of drawn as well. So identify the side of the triangle to be found. Redraw a simple triangle with the most important information provided. Okay, so all of this is from the information in here. Okay, so it's 150 degrees to there. Okay, so we know that because, I might just expand that, because that's 150 degrees, that must be 30 degrees. Oops. Why is it 30 degrees, I hear you ask? Because it's that straight line here. So these two have to add up to 180 degrees. So that must be 30 degrees in there. Now because that's 30 degrees in there, remembering that these two lines are parallel, and with our angles of parallel lines, our rules of parallel lines, we know that that's also got to be 30 degrees. Okay, so that's how I get this information here. Okay, now it's 220 degrees around to there. So I know it's 180 degrees to there, so that must be 40 degrees. So it's 30 degrees in there, 40 degrees in there. So it's 40 degrees in there. And because of that, knowing that, okay, these three angles have to add up to 180 because they're on a straight line. So 30 plus 40 gives me 70. So that angle in there, that part of the triangle, has to be 110 degrees. So looking at this, I have that line there, that length there, and that angle there. You know, the angle between them, and I want to find the length opposite. What does this look like? Oh, this looks like cosine rule. So we can find that length as we're given the two sides and the angle between them. So I've substituted it all in there. There's my cosine rule, substituted it in there to get to 6.65 kilometers, that length. Okay, so we know part of our answer. Now, we've got to figure out the direction, that true bearing. We need to find the angle between the direction of the second and third legs first. So we want to find, as I was saying before, this angle here. Now, an easier way to find that might be to figure out that angle there, because we know part of it. But anyway, so we're looking for the angle BAC, that angle in there. So let's have a look at these little diagrams. So we know it's 40 degrees from here to here. So because these are parallel lines, okay, with that line between it, if it's 40 degrees there, it has to be 40 degrees there. So if I figure out that angle in there from my triangle, I know what that angle must be. And that's my true bearing back home. And that's what I want to figure out. Okay. So we know all three side lengths now. So we can use cosine rule if we like to figure out this angle, that angle A, because we know that one there and the other two sides, and we want to figure out that angle. Okay, so I've substituted it in here. So there's my rule, cos A, and we're going to find that angle. Substituted it all in. 5 squared, c squared, 25 degrees. So calculate the angle of the turn from north bearing, so it's 15 degrees. So our final answer is that the bearing is 15 degrees true. You can see I've got the 0 there to make it 3 digits. And the distance covered is 6.65 meters.